Yes, Shangita, you can ask your question.
So let me ask you, have you visited a electrical substation physically?
Yes, sir, I have visited.
Where it is?
Yes, sir, visited.
Okay. At what voltage level the substation was? Is it 400 kV, 765 kV? Have you visited 765 kV substation?
Sir, 132 kV substation.
Okay. Okay. But nowadays, our national grid, it is 400 kV national grid. And there is one, we have upgraded to 765 kV grid. Most of the upcoming substations are mainly 765 kV and 400 kV. So, in an electrical system, substation is used to control power. We use normally in an electrical system, there remains generating station, there remains load. So the transmission system transfers the power from generating station to load. It has two parts. One is transmission system, another is distribution system. Distribution system actually transfers the load from transmission system to distribution system, and then distribution system finally feeds the load. In a transmission system, there are two parts. One is substation, another is transmission line. So all of you must have seen the transmission line running through the paddy field, across the paddy field you have seen. But in a substation, we control the power, how much power will flow to the transmission line, through the transmission line. That is controlled from substation. Okay. So I think go to next slide. Yes, transmission system has two parts. One is substation, another is transmission line. Next slide. So what is a substation? A substation is an electrical installation where power is controlled for transmission and distribution purpose. There are different type of substations. One is power evacuation substation, another is transmission substation, and another is distribution substation. These are mainly based on location of substation, where the substation is located in the electrical system. Based on that, these naming are done. In a power evacuation substation, mainly it is located near the source of power. That means it is in the generating station. These substations are located. A transmission substation is located intermediate between generating station and distribution station. Okay. And in a distribution station, this is the last substation. From here, the load is fed. Next slide. Power evacuation substation, it is basically located near generating stations, and it is built by generation utilities. Generation utilities means the generating companies, the power company which is producing the power, means who have built the power station, that is called generation utilities. Okay. So they decide the substation voltage level, in how much voltage level it will be transmitted. So that is decided on based on different criteria. How much power has to be evacuated, in which grid network that power is to be fed, and what is the distance of the generating station from the grid. Considering all these factors, they decide the level of the voltage level of the substation. Nowadays, it is preferably 765 kV, 420 kV, that is peak voltage, and 245 kV. Quantum of power to be distributed, it depends on the capacity of power plant. Earlier, it used to be 250 megawatt power plant. Now, then increased to most of the time. Now it is almost obsolete. 250 megawatt substations, generating stations, thermal power plant. Mostly it was 500. Now 500 we have crossed. Then 660 megawatt unit, and nowadays it is mostly India is making mostly 800 megawatt units. So in a generator, voltage is generated at only 17.5 kV level. But with this level of generated voltage, we cannot send it very long distance, because there will be huge losses and all the power will be wasted. So we have to step up the voltage so that it can be transmitted to a long distance. So, but how much it has to be stepped up, that depends on the distance from the grid, how long it has to be sent. The longer the distance, the higher will be the voltage level. So earlier we had mostly state grids. So we used to feed to state grids, and it is used to be 220 kV. Then a national grid was developed at 400 kV level. So most substations are coming nowadays only 400 kV level. 765 kV level substations are generally not made at generating stations. They are basically transmission substations based on the high amount of power, when bulk amount of power has to be transferred. So the 765 kV is more suitable than 400 kV substation. So depending upon the quantum of power, this is basically decided. Initially, the utility company, mostly the state electricity boards and power grid, they do a system study, how much power has to be transferred from which place to which place, and where the substation has to be located. All these are done by these companies. They do the first, they study the system, they evaluate the criteria of the substation, at which voltage level it has to be constructed, and accordingly the design of the substation is done. So I think go back to 1 or 2 slide. See, transmission substation, it is based on the transmission grid network. It is located, and quantum of power to be transmitted. That is the main criteria, and the length of the transmission line. Preferred voltage level is 765 kV, 420 kV, 245 kV, 145 kV. These small voltage is based on requirement only, but when we transfer power from grid, mostly 765 kV transmission lines and 765 kV substations are preferred nowadays, because this saves energy. There is loss is minimized at 765 kV level, and in fact the experiment is going on to upgrade it to 1200 kV level, although it is not yet successful, because if we step up the level, then we have to make the equipments at that level, 1200 kV circuit breakers, current transformers, CVT. So that is now in experiment stage, developing stage. So at present, basically mostly 765 kV and 400 kV substations are in service in India. Next. Distribution substation, it is located near to the load. When the power from generating station has been transferred by transmission system, it has come to 765 kV level or 400 kV level. but that at that high level voltage level, we cannot use that high voltage directly to our loads, because our loads are not for that much high level of voltage. So what we do, we then step down it to the required level. According to the industry, the requirement is somewhere it is 11 kV, somewhere it is 6.6 kV or 33 kV. So in a transmission system, when we are sending power from generating station to grid, then there it is 400 kV level. From generating station, we step up the voltage to 400 kV level and directly connect it to 400 kV grid. But in a substation transmission load, where load is required, suppose we are taking power from grid and we have to feed some load in an industrial area. So we are taking power either from 400 kV grid or from 765 kV grid. So after transmitting the power from grid to near the load area, we have to step it down and we have to bring it to the required voltage level. So there it is, another receiving end substation is there, which will reduce the voltage from 400 kV to or 765 kV to the required level. And from there may be multiple loads. In an industrial area, there is not that only a single load. So we need a distribution substation at 11 kV level. From that substation, many feeders are there feeding different loads. So basically, in a substation, there remains some circuits or feeders which are connected in a bus system. So we'll come to that later. Let us go to next section. If you go to a substation, you will see this picture. Here, this is a transmission substation, for section of a transmission substation. You see this is at the end 1 and 12. These are two transmission line towers. These are the transmission line towers. Voltage is transmitting. One is incoming transmission line. Voltage is coming through, say, suppose from one side, the voltage at any level, the voltage is coming. So we are taking this voltage, putting it in the bus system. Here, if you see number 5, disconnected switch. Above this disconnected switch, here it is a bus. There are two bus, main bus 1 and main bus 2. We keep put the first receive the power and put it in a bus. Then from this bus, we take power and transfer to other end where it is required. And in between, that control of power takes place. How much power has to be sent and where, in which feeder, how much power has to be transmitted. That all thing that is controlled and decided in this substation. So if you see, there are circuits. These are called bays in a double main and transfer bus system. But if you go for, okay, I think go to just previous. Yes. So there are circuits are formed. But what is a circuit? These are the elements of a circuit. You will see power transformer, current transformer, circuit breaker, disconnected switch or isolator, lightning arrestor. All these are connected in a sequence. When connected in a sequence, it forms a circuit. Next slide, please. So what I was telling, in a substation, what happens? Many circuits are connected in a busbar system, busbar scheme. So what is this circuit? Some are incoming circuit, some are outgoing circuit. Incoming circuit means power comes to the substation from generating station or from the grid through this incoming circuit. And outgoing circuit is we deliver the power to the distribution substation or receiving end substation through the outgoing circuit. Okay, in a substation, normally there remains more outgoing circuit and one or two incoming circuit, because bulk amount of power is received through the incomer circuit, and then it is temporary storage, like just like water tank on the top of the buildings. Water comes from the ground and it is stored there, and then many pipelines are connected to each flat or each apartment. So like that, in a substation, the main power comes through the incomer circuit. It is temporarily stored in bus bar, and from bus bar it goes to the outgoing circuits to different loads. But it is not that like water tank, it is water is always stored. Here, what happens? Total incoming power is always equal to total outgoing power. So it may uh, you may think that power is stored, but it is actually not stored. It is a temporary kind of stoppage and then going to different direction. Okay, so this busbar scheme, we make it a different kind of busbar scheme based on our requirement, cost, and all those things. Many types of busbar scheme are designed. So if you see, it may be single bus system, it may be two main bus system, it may be one main and one transfer bus system, it can be two main and one transfer bus system, or it can be 1.5 breaker system. So next slide. So yeah, this switching scheme or busbar scheme, how it is selected? These are the criteria based on which these selection schemes are prepared or designed. Reliability, flexibility of operation and maintenance, simplicity of control and protection. All these are criteria. Based on these factors, the scheme is designed, is selected, which particular scheme will be used in this. Suppose we are constructing a new substation, then we have to decide at the design stage which busbar scheme will be used. So for that, we have to, these are the criteria. Based on these criteria, the busbar scheme is decided. And most important is cost, project cost. Okay, next slide. This is a picture of single bus system, how the circuits are connected here. Here only one main bus remains, and circuits, different circuits are connected to this main bus. And all these circuits are called bay. There are 6 bays in this substation. Bay 1 is a feeder, outgoing feeder. Bay 2 is an incoming transformer feeder, and bay feeder 2, this is a bay 3 line feeder, outgoing line feeder. So here we see that voltage is being received through transformer in this main bus, and the same power is flowing through these outgoing feeders to different load or different other substation. Okay, next. So it has some advantages and some disadvantages. Advantage is it is very simple in design and very easy to maintenance and less costly. But it has some inherent disadvantages. What is that disadvantage? In a substation, fault may occur anytime, but if a particular fault occurs in a particular feeder, that feeder is immediately isolated by protection system. But if the fault occurs on the bus, what will happen? The bus will be isolated, means bus will be dead. Once the bus is dead, all the circuits are dead. Power supply will be totally disrupted. All circuits are connected to a single bus, and the if there is any fault on that bus, then the entire substation collapse. So that is the main disadvantage. So to avoid to upgrade, we use double main bus. Go to next Next slide. Here it is double main bus system. Here the arrangement is slightly different. We have two main bus 1 and bus 2. These main bus, in each bay, these buses are connected, interconnected through isolator and breaker, and feeder is connected to this common point, so that we can connect this feeder to bus 1 or bus 2 of our, according to our requirement or choice. So in this case, there is some flexibility over the single bus system. In this case, suppose feeders are distributed not on the same bus, they are distributed on different buses. Some feeders are kept in main bus 1, some feeders are kept in bus 2. So if any fault occurs on bus 1, only few feeders will be power flow to only few feeders will be disrupted, others will be intact. And in that case, if suppose we have to take up some maintenance work of bus, so suppose bus 2 we have to take maintenance, so what we can do, shift all the feeders to bus 1 and then take shutdown of bus 2 and do the maintenance work. So power flow will not be interrupted. But in a single bus system, if we have to do any maintenance work on main bus, then what will happen? The entire substation will be stopped. No power flow will be there. Here that problem is resolved by making the bus distributed, making two bus and feeders distributed on two different buses. Okay, so here one, suppose when normal running condition, it can be two different conditions. Both the buses can operate in sync, or both the bus can operate separately. Suppose I have two incoming feeder. Okay, I want to make the two bus independent. So in that case, what will happen? What I will do, I will connect one incomer circuit to bus 1 and another incomer circuit to bus 2, and these two buses will be entirely different, entirely independent. But suppose I need not do that independent operation. I want to be both the buses to be connected in sync, so that any feeder can be connected to any bus. So in that case, there is a bay. It is called bus coupler bay. This bus coupler bay actually couples. This is a circuit starting from bus 1 ends to bus 2. That means it connects the two buses. It has a circuit breaker in between, and both side isolators are there. So this bus coupler bay, what it does, it synchronizes the two bus. Suppose why it is synchronization is required, we can connect the two buses directly, but not possible, because suppose my incomer 1 is coming from one circuit, one generating station, and incomer 2 is coming from another generating station or another grid substation. Then power of the two incoming power, frequency of the two incoming power may or may not be same. So if the frequency of the two incoming power is not same, we cannot connect the two different two powers with different frequency directly. Then there will be huge accident. So what we have to do, we have to synchronize the power. Frequency of both the power should be same. Then only we can connect the two buses. For that purpose, here this bus coupler bay is there, which synchronizes the power of both the buses and then connects, and it makes a single unit. Okay, next slide. Double main bus system, its features. This has got flexibility of transferring any circuit to any of the bus. For maintenance or on fault occurrence on one bus, only that bus becomes dead while the other bus remains in service. So no service interruption. For maintenance of a circuit breaker, that particular circuit has to be taken out of service. Yes. To overcome this, an additional bypass isolator is provided as indicated in the figure below. This is something I have not shown because nowadays that system is not much used. Okay, next slide, please. This is the improvement over double main and double main bus system. This is a double main bus and transfer bus system. Here we have one extra facility. We have all the facility of double bus system, but in a double bus system, if I have to take maintenance or any other problem comes to one circuit breaker of a feeder, suppose. In case of double bus system, what I have to do, sorry. Okay. In case of only double main bus system, for maintenance of circuit breaker of any feeder, I have to take shutdown of that feeder. Power flow of that feeder will be stopped because I have to disconnect the feeder from main bus. Then I have to do maintenance of the circuit breaker. And after completion of maintenance, then I can again connect the feeder, close the circuit breaker and connect it to bus. During the maintenance period, maybe 10 hours, 8 hours, 12 hours, there will be no power flow in that circuit. But in a double main bus and transfer bus system, we can do the maintenance work of the circuit breaker without disturbing the power flow. How? Here, additional bus is used. This is transfer bus. So we will charge the circuit that feeder through transfer bus, so that power flow continues through transfer bus to that particular feeder, for which I have to take shutdown of the circuit breaker. So how it is done? Here, one apart from that bus coupler bay, one additional bay is there, bus transfer bay. If you look at this portion, this bus transfer bay, through this bus transfer bay, 3 buses are connected: main bus 1, main bus 2, and transfer bus. There is a breaker here and isolators from bus 1 isolator, bus 2 isolator, and then this is transfer bus isolator, and this is breaker. With this transfer bus, we can connect main bus 1 or main bus 2, whichever is preferable, required according to the situation. How it is done? Just like this system is just like bus coupler system. It is another kind of bus coupler, but here it connects main bus with transfer bus. Okay, that is why it is called transfer bus coupler bay. And this is or TBC. This is TBC breaker. So suppose here we have 4 outgoing feeder. We have to take shutdown of this circuit breaker of feeder 2, suppose. So what we will do? We will first, and at the same time, there will be no power interruption. We will do take the shutdown of the breaker, but there will be no interruption of power in this circuit 2, outgoing power. Power will continue to flow, and at the same time we will take shutdown of the breaker. How is it possible? See, I am telling how it happens. In that case, we have to charge this transfer bus from any of the main bus as per suitability. Suppose we decided that we will charge this transfer bus from main bus 1. So what we will do? We will connect this isolator, and we will sync. Again, we have to sync. Whenever we connect to bus, without synchronization, we cannot just simply directly connect it. So through this breaker, we charge this transfer bus from any of the main bus. Suppose main bus 1. Now this transfer bus is charged. Main bus 1 and main bus 2 is charged. All three buses are charged. Now we will connect this isolator. Sorry, feeder 2 means this isolator. If we connect this isolator, this bus originally, one thing we have to check which bus to be which main bus to be connected to transfer bus. That is decided from here, where in which bus the feeder is connected. The feeder can be connected either main bus 1 or main bus 2. If it is connected in main bus 1, then we will charge the transfer bus from main bus 1. Okay, because in that case, the power frequency will be same in both main bus 1 and transfer bus. And it will be in sync, main bus 1 and transfer bus. Now come here, we connect this transfer bus isolator. So what will happen? Power is already flowing from this main bus 1 to this circuit. And at the same time, power from this main bus 1, it comes to this transfer bus, and through this route, it is connected to this feeder. That means in this position, power is flowing from two paths to the feeder. One is directly from main bus 1, and another path is from main bus 1 to transfer bus to this feeder. Now the power flow is established from main bus 1 and transfer bus. Under this condition, we can take switch off this breaker, which is connected to main bus 1, main feeder breaker, which we have to do the maintenance work of with breaker. So now if we stop this breaker, trip this breaker, power will continue to flow in this circuit without any interruption through this transfer bus. Am I clear?
Yes, sir. Yes.
Okay. So this is the advantage, improvement over double main bus system. In a double main bus system, we did not have this facility of uninterrupted power supply when we are taking shutdown of the main circuit breaker. Okay, in this case, we can have that facility. This is the improvement. This is the double main and transfer bus scheme. Okay, next slide, please. These are the features. This has got flexibility of transferring any circuit to any of the main buses. For maintenance or any fault occurrence on a bus, particular bus only becomes dead while the other bus continues to be in service. This is the feature of two double main bus scheme. Here the same facility is available, but here additional facility is available that if any circuit breaker can be taken out for maintenance by transferring that circuit to transfer bus and transferring its protection to transfer bus coupler circuit breaker. So let me go back to this scheme page, previous slide. Here. Now you should have asked the question, students, that when this breaker is taken out, who will protect this line? To which breaker, if any fault comes during the maintenance of this main circuit breaker, how the line will be isolated, how the fault will be cleared. In that case, suppose I have taken the shutdown of this main breaker, I am doing maintenance work. The power is being flowed through this transfer bus system to this feeder, and at that time a fault has come to this transmission line. So what will happen? Who will take care? This transfer bus coupler breaker will take care of the line feeder, and its line feeder, every protection will be taken care of by this protection scheme of this transfer bus protection scheme. Because in that case, this line is broken when I have taken the shutdown. Power is flowing through this main bus through this breaker to transfer bus, and from this transfer bus to this line, bypassing these isolators of main bus 1 and main bus 2 and breaker. So basically this line is connected to this main bus 1 through this transfer bus coupler breaker. So all protection of the line will be taken care of by the protection scheme of transfer bus coupler break, and this breaker will trip to isolate the fault in case fault happens to this line when the main breaker is under maintenance. But here one problem is there. We have only one transfer bus breaker. Suppose one breaker, we have one feeder has we have charged one feeder through transfer bus, and at that time we are doing maintenance of this bus feeder 2 circuit breaker, and at that time some problem has taken place in this circuit breaker of feeder 1. So how can we make uninterrupted power service to circuit 1 also and take the breaker out for maintenance? That is not possible, because we have only one breaker, and through only one transfer bus breaker, and through one breaker we can charge only one feeder. So if there is a problem, if there is simultaneously problem in two circuit breakers, two feeder breakers, we cannot charge both the lines through this single transfer bus coupler breaker. So that is the limitation. At a time we can take out only one breaker, not more than that. So that is the shortcomings of this system. So we have improved over this. Again, design has been improved to overcome these shortcomings. Then comes the 1.5 breaker system. Okay, let us go to the next slide. Next. This is 1.5 breaker system bus scheme. Here we have improved over that double main and transfer bus system. Here what happens? We have two main bus 1 and bus 2. There is no transfer bus, but we are two feeders are there, but we have one additional breaker. Each feeder has its own breaker. This yellow color, this is breaker. This feeder is connected to this bus 1 via this its own breaker. This feeder 2 is connected to bus 2 through its own breaker, and there is one bay. This is called tie bay. This is basically nothing but kind of bus coupler bay. We have this feeder bus 1 or bus 2 connected to a breaker. This is called tie breaker. So what is happening here? For every two feeder, we are using 3 circuit breakers. That is why the scheme is named 1.5 circuit breaker. That means per feeder, we are having 1.5 breaker. For two feeder, there is 3 breakers. So per feeder, there is 1.5 breaker. That is the name. From that, the name arises 1.5 breaker system. So here, how the scheme has been improved? It is basically this entire system is called one dia. This feeder 1, feeder 2, and their tie bay. This entire system is called dia. This is one dia, dia 1, dia 2, dia 3, dia 4, like that. The scheme is feeders are arranged in this fashion. These feeders may be incoming feeder, outgoing feeder, it doesn't matter. We can connect to any incoming feeder or outgoing. It may be both the feeders are in a dia. Both the feeders may be line dia, outgoing feeder. It may be both the incoming dia, incoming feeder, or it may be one incoming feeder, one outgoing feeder. We have that flexibility because normally it is isolated. One feeder is connected to one bus, another feeder is connected to one bus, another bus. If we need to sync it, we can sync both the buses through this tie breaker. So this tiebreaker is acting as a bus coupler breaker. As in double main bus system, we had one bus coupler breaker. So through that bus coupler breaker, we used to connect two bus. Here we can do that. Suppose this bay 2, this is a tie bay between bay 1 and bay 3. This is a tie bay. When this tiebreaker is open, then bus 1 and bus 2 are operating independently. They are not connected. But if we connect this breaker, close this breaker, what will happen? Power will, this breaker at one point, this side, power is coming from bus 2, and this side power is coming from bus 1. So if we close this breaker, so what will happen? Bus 1 and bus 2 will be synchronized. Then the entire bus becomes a single unit. So in this way, it is operating as bus coupler breaker. So that double main system, double main bus system is included in this system. Now let us come to how the transfer bus facility, whatever facility available in transfer bus scheme, double main and transfer bus scheme, that facility also is available in this scheme. Let us see how it happens. Okay, next slide. That is also a 1.5 breaker system, but only the configuration is different. This is called D type configuration, and the previous slide it was I type configuration. Okay, here the arrangement of tie bay is in a different condition. This, which one, D configuration or I configuration to be used, that is decided on different factors, including land availability, shape of the land, directions of transmission lines, from which direction it is coming and from which direction outgoing lines are going. So all these factors, depending on all these factors, this configuration is chosen, whether D type configuration or I type configuration to be used. Okay, let us go back to this previous slide, I type configuration. Okay, we were here. So we have seen how the bus coupler bus coupler breaker of double main bus system is working here. So that facility is included in this scheme. Now we'll see how the transfer bus scheme, double main and transfer bus scheme facility is also included in this scheme. Suppose I have this dia 1, bay 1, feeder 1 is charged through bus 1 and feeder 2 is charged through bus 2. My tie bay breaker is open condition. So now these two feeders are being fed from these two different buses independently. Suppose some problem comes to this breaker 1 of bay 1. Okay, so I have to take shutdown of this particular breaker for maintenance work. So what we'll do, that uninterrupted power supply, here we can establish how we will, what we will do first, we will close this circuit breaker, this tie bay circuit breaker. Okay, bay 2. So what will happen, then bus 1 and bus 2 will be connected. All three breakers are closed, both the buses are connected and all are in sync condition. Under this condition, if we switch off or trip the circuit breaker of this bay 1, then what will happen? This power to this feeder 1 will continue to be supplied from bus 2. So we have taken shutdown of this breaker, bay 1 breaker, but still power is flowing through this tie bay to the feeder without any interruption. So the facility of double main and transfer bus scheme is also included in this 1.5 breaker scheme. So we have both combined in a single bus scheme. Then what is the advantage? One more advantage is there, that in a double main transfer bus scheme, if we can feed any one feeder through the transfer bus at a time. Suppose if problem comes two different breakers of two different feeder, we cannot have that facility to have uninterrupted power supply to both the lines. We have to take shutdown of one. Power flow will be interrupted in one feeder, and we can make uninterrupted power supply to one feeder. But here we can make uninterrupted power supply to both the feeder. Suppose there is problem in two circuit breakers of two different feeder. In that case also, we can make uninterrupted power supply to both the feeders. How? Let me tell you. Ma'am, okay, go back to that previous slide, previous slide. Yes. Suppose this is dia 1. This breaker has some problem. Okay. And another, this dia 5. Here, this bay number, this is feeder 10, bay number 15. This breaker is having some trouble. This feeder 10, circuit breaker 10, and this circuit breaker 1, bay 1. These two feeders, these two circuit breakers are having problem. We have to take out both the circuit breakers. Had it been the double main and transfer breaker, we have to make one circuit off, because we cannot charge two feeders through a single transfer bus coupler breaker. That's why we have only option of one feeder charging through this transfer bus. But here we can supply uninterrupted power to both the circuits when both the breakers are in shutdown condition. Let me tell you how. Suppose this breaker 1 is problem. So what we will do, as I told you earlier, we will close this tie breaker. So bus 1 and bus 2 will be connected. Okay. At the similarly, in dia 5, this is bay number 13 and breaker number 13, and this is breaker number 15, and there is tie breaker number 14. So we will close this breaker also. So what will happen? Bus will be connected from this point also through breaker number 13, 14, and 15. And bus is connected through this line also, breaker number 1, 2, and 3. So basically, both the buses are synced. It is now a single unit, not the separate bus. Now it is a single bus connected at two different points. Now this problem, breaker 1 problem, we can switch off this breaker. So this breaker will be isolated, and at the same time we can switch off this breaker number 15. So it will be taken out for maintenance. So we can take out two feeders simultaneously. In fact, we can take out many feeders simultaneously. For each dia, we can take one breaker at a time. And we will take one breaker of each dia for maintenance. We can take out one breaker from each dia. So simultaneously, if there are 6 dia, we can do maintenance of 6 breakers at a time without any disruption of power flow. So this is a very big advantage. This is a very big improvement, and that's why in all 765 kV and 400 kV system, this 1.5 breaker system bus bar scheme is mostly used. Rarely you will find double main and transfer bus. Mostly you will see this 1.5 breaker system. But one disadvantage, it is very costly, because we have to provide one extra breaker for every 2 bay. So for 5 dia, 10 bays, Here it is 6 dia, 12 base. We have to provide 6 additional breakers for getting this flexibility. So it is a costly scheme. So again, cost optimization is the design criteria. How much power will be flow, how much revenue will be generated, and according to that, whether providing these extra breakers are cost effective or not. That is one big point of consideration. Okay, so I think we have understood this 1.5 breaker system very clearly. If anyone has any question, you can ask me now. Okay, let us go to next slide. This is the same scheme, only thing is configuration is different. This is feeder 1 and feeder 2. For this, tie bay is here, the tie circuit breaker is here, bay 2. For every 2 main feeder, there is 1 tie breaker, and same condition there, but this is D configuration. Only the arrangement of tie bay is different, and main bus and main bus 2. Here both the buses are placed in the center of the substation, and in previous arrangement the buses are apart, bays are within the substation, and buses are at both end of the substation. Next slide, ma'am. These are the features. It has 3 circuit breakers for 2 circuits. One is line, another is transformer or bus reactor, or both are lines. No changeover of line from one bus to another is required. For circuit breaker maintenance of any line, the load gets transferred automatically to the other bus. For maintenance or an occurrence of a bus fault, all the interconnections will be on healthy bus and no disturbance to the circuit. Even if both buses become dead, the circuit can still be in service through the tie circuit breaker. This needs some explanation how it can happen. If one bus is dead, another bus is live, and we can transfer all the feeders to that live bus, and we can do maintenance for a dead bus, that is okay. But here what happens? Additional facility. If both the buses are dead, then also power can flow through this substation without any interruption. How? Let me show you. Ma'am, go back to that previous slide. Yes. Suppose this feeder 1, it is power is flowing to this feeder through main bus 1, and another this feeder 2, power is being fed from main bus 2. Now suppose both the buses, and in that condition, let us connect this tie breaker. Suppose it is not connected, okay, and both the one fault come and both the bus get tripped. So what will happen? This feeder is energized from other end up to this point, and this feeder is energized from other end up to this point. Now if we connect this breaker, power will flow between from this substation through this path to this substation. Depending on the requirement, direction of power flow will be decided, whether it is from substation 2 to substation 1 or it is from substation 1 to substation 2. But still, their power flow can be there even when both the buses are under maintenance or any fault has occurred in both the buses. When my both buses are out, in that condition also, power flow can be done through this breaker. That is one of the biggest advantage. That is why here it is written. Ma'am, go to next slide. Even if both buses becomes dead, circuits can still be in service through the tie circuit breaker. This is one of the biggest advantage. This is the worst case scenario. Normally, it does not happen, this situation. If this situation happens, some of the engineers we'll get show cause notice how these both the buses can be disrupted at the same time. So normally this is a very rarest incident of both the buses are dead. Okay, let us go to next slide. Now we will go slightly in detail what is there in a substation. We have seen a substation is where many circuits are connected, interconnected through a busbar scheme. And there are different type of busbar schemes, single bus, double bus, all those things. Now we will concentrate on circuits. What are the elements of the circuits and how they are connected. So in a substation, there are primarily three system works. One is primary system, another is secondary system, another is auxiliary system. Let us see how each system, what are the component of each system and how they are, how they work. Okay, ma'am, next slide. Primary system, it has two components we have seen. One is main equipment, another is engineered items. What is engineered item? I'll come to there. Let us first see what are the main equipments of a bay or primary system. This is transformer, circuit breaker, isolator, current transformer, voltage transformer, surge arrestor, wave traps, CVT, and for reactive power compensation, there is either capacitor bank or reactor. So depending upon the type of feeder, whether it is incoming feeder or it is a line feeder or outgoing feeder, these equipments are connected in a particular sequence to enable power flow. If it is a transformer feeder, then there will be transformer, circuit breaker, isolator. This current transformer and voltage or CVT, this is common, and there will be surge arrestor. But wave trap will not be there, and these reactive power compensation components will not be there for a transformer bay. But if it is a line feeder, in that case, in case of line feeder, transformer will not be there. There will be circuit breaker, isolator, then CT, CVT, surge arrestor will be there, wave trap will be there. And depending upon the length of the transmission line, what reactive power compensation is required, it can be a reactor or it can be a capacitor bank. Where line length is very long, there this reactor is used, line reactor is used, and depending upon the compensation required, the capacitor bank is used. Next slide. This is the engineered items. These are bus material, earthing material, and cabling system. These are engineered items. That means what those equipments are not engineered, and not like that. Engineering is done for everything. The total substation is designed depending on power requirement and other conditions that I told in previous slide. So total system is designed. But what happens? These main equipments, breaker, isolator, these are single equipment and they have their specification. You will buy these equipments from the manufacturers, or you will give the specific rating. They will provide you the equipment. But these systems, these are busbar material, earthing material, cabling system. These are not fixed. You have to calculate how much quantity of busbar material is required for my substation, how much earthing material is required, how much cable is required, of what size of cable is required. All these need detailed engineering based on the capacitance of the each circuit and total number of feeders of the substation. These quantity you have to design and accordingly you have to procure. These are not fixed single one item. Suppose the main bus, we have to do main bus. So through moose conductor. Different type of conductors are there. Then again, which type of conductor to be used? Is it bull conductor? It is moose conductor. That is also depending upon the power handling capacity of bus. That conductor size will be decided. And then the quantity of that conductor, that has to be calculated according to the design of the substation. Okay, so this strong bus, it is conductor is required for stringing of the conductor. We need stringing insulation, stringing insulator, disc insulators, and stringing insulator hardwares. That each thing we have to find out, we have to calculate, and accordingly we have to decide the quantity. That's why this is called engineered items. If it is a rigid bus means the main bus is made of aluminum tube instead of flexible conductors. Aluminum conductors, it is made up of aluminum tubes. That's why it is called rigid bus. So in that case, we have to keep the bus in upward position horizontally at the relevant height, maybe 8 meter or 15 meter. So for that we need bus post insulator for supporting the aluminum bus. So this quantity we have to actually find out, calculate, design, and accordingly we have to procure. Again, these clamps and connectors are required for connecting the equipment like isolator. One side of, if it is a bus isolator, then one side of the isolator will be connected to main bus. Another side of the isolator will be connected to circuit breaker. This connection will be done. It may be rigid connection or it may be flexible connection. If it is a flexible connection, it will be connected through conductor, maybe moose conductor or bull conductor. If it is a rigid connection, then this isolator will be connected to bus through aluminum tube. That also of different size, maybe 4 inch, somewhere it is 6 inch. But how this conductor or aluminum tube will be connected to the isolator? We cannot simply put and it is getting connected. It is not like that. We have to place connectors between the isolator and tube. Similarly, between the breaker and tube. The tube will be connected to breaker through some connectors or clamps. So we have to design in detail these clamps and connector, type of connector, what type of connector is required, what type of clamp is required. That will be designed based on the terminals of breaker and isolator. Because we have to connect the bus, aluminum tube, it is a round pipe type of thing, and the breaker terminal is a flat surface. So we have to make a connector, basically an adapter, which is suitable for connecting a flat surface with a tube. Okay, so that through that connector, the tube will be connected to breaker. What that connector will have? It is a single piece, but two sides are different. At one side it is flat type, and at another side it is round type. That round type will be connected to aluminum tube, and the flat type will be connected to breaker. So this is, we have to design it. For each connector, each equipment, we have to design the appropriate connector. So that is why it is called engineered item, because detailed engineering is required to identify the type of connector required. Suppose the breaker, 400 kV breaker, there are many manufacturers. Siemens makes breaker, GE makes breaker, ABB makes breaker. We can purchase any breaker from any of these vendors, but The problem is each having different type of terminal pad design. So we have, for design of this connector, I have to have first the drawing of the breaker, from which vendor I am taking the breaker, and the detailed drawing of that circuit breaker, and I have to find out the terminal pad, how it is designed. Accordingly, I have to design my connector so that that connector connects the aluminum tube to this breaker. If suppose I have one Siemens breaker connected in circuit, now I want to change it and I want to replace it with an ABB breaker. So it is not necessary that the terminal pad of ABB breaker will be same as the terminal pad of Siemens breaker. So the earlier connector may not be, maybe it can be used if both the terminals are same, but not necessary that always it can be used. It cannot be used if the terminal pads of ABB breaker is different from that of Siemens breaker. So if I want to replace that breaker, at the same time, I have to check my connector type, whether I have to change the connector type or not. So these are the things we have to design very minutely, and in a substation, hundreds of connectors are used. So we have to design each and every type. At every joint, we have to design. In a BPI, suppose our main bus is rigid type main bus. A main bus runs through the substation from this end to that end. All the feeders are connected to this main bus. But you cannot make a single piece of aluminum tube of length 200 meter, 400 meter, 500 meter length of single piece of aluminum tube of 500 meter length. It is not practically possible. So aluminum tube is manufactured in a standard length of 6 meter length. So we have to connect 100 for a 500 meter length main bus. We have to connect in each phase 600. If it is 600 meter, we have to connect 100 aluminum tubes. For suppose R phase bus, we have to connect 100 aluminum tubes. So this is a huge task, and for every 6 meter there is a joint, and for that joint we have to either use connector, but in case of main bus we do not use connector. We directly join the aluminum tubes through welding. Aluminum tubes get connected through aluminum welding, but I have to keep this entire length of the bus on my BPI, bus support insulator. But I cannot put simply the bus on that insulator, because insulator top surface is flat and bus tube is a round surface, and if we keep it on it simply, then the bus will roll to ground. So I have to put a connector on top of each BPI bus post insulator for holding the bus. Now we have some connector we have designed which will be fixed on the flat surface of BPI, flat horizontal surface of BPI, and it will hold the aluminum tube on top. But this 600 meter length, we cannot produce by welding one piece of 600 meter length. We have to break it in between, just like in a rail line, there is some gap and slip in the rail line, rail track in connection. The same is here also. We cannot make a single piece of aluminum tube of 600 meter length. We have to break at places and have some gap in between, because with temperature variation, season variation, temperature variation, there will be some expansion and contraction of the tube. So we have to design our connectors to accommodate that expansion and contraction of the buses also. For that, we have to make some flexible connectors at joint of two pipe and rigid connector where the bus has to be kept hold on the BPI and joint is not there in between. But where there is a gap and two separate bus, if there is a gap, means two separate tube. No, now we have to connect it through flexible connector so that the electrical path remains through, and at the same time aluminum tube break is there. So we have to design a special connector there, that is flexible connector. So like this, every situation, every joint with different equipment, we have to design different type of connectors. The connector for connecting conductors to surge arrestor is different from connector of conductors for connecting to CVT. Similarly, the connector of CT is different from CVT. Connector of CT is different from breaker. Connector of breaker is different from isolator. Again, each equipment is having many types of connectors, rigid connectors, flexible connectors, and then again, whether aluminum tube to be connected to that equipment or conductor to be connected to that equipment, depending upon that, the connector will be changed. Again, suppose conductor is to be connected, the main bus isolator will be connected to main bus through conductor. Then what will be the approach of this conductor when it is connecting to isolator end? Whether it is coming vertically to isolator or it is coming horizontally to isolator. Depending upon that, the design of the connector will change. So in so many factors, we have to totally design how the interconnection will be done, with what connector means conductor or tube is to be used for the interconnection, and that too, how it will be connected. It will be horizontal approach or it will be a vertical approach. Based on all these factors, these connectors are designed. Next is earthing material. Sorry, ma'am, you go back to, yes, earthing material. You know, earthing system is a very important system. This is a safety measure. Safety of the personnel and equipment has to be ensured. For that, you have read that touch potential, step potential, all that has to be maintained so that everybody remains safe. So for this, we have to design the earthing system. You know that a mesh is created all to entire substation area. That is through a mesh is created, that is through MS rod, mild steel rod. Okay, mostly in India it is used mild steel rod. In abroad they use copper strips, but here in India it is mostly mild steel rods are used. Again, we have to design it very carefully. How many horizontal bars to be placed, how many vertical bars, I mean, two axes, this is horizontal plane, it will be underground. So how many bars to be placed in X direction, how many bars to be placed in Y direction, that we have to design. Quantity of rod we have to design. So for that, we have to find out the resistivity, soil resistivity. Depending on soil resistivity, that will be decided. I think I have crossed the time limit. Let us finish. So in this way, main earth material we have to design. Then we have to design cable system. Just a minute. Okay. Next is secondary system. Secondary system, we have many things, control panel, protection panel, supervisory control and data acquisition, that is SCADA. or substation automation system, or SAS. So another system is metering system and communication system. This control panel, this is used for operation of equipments, circuit breaker, isolator. These are equipments which can be operated from locally at yard end, or it can be remote operated from control room. When it is to be operated from control room, this control panel is used. And protection panel, all relays are installed in this protection panel, and the entire protection scheme is implemented through this protection panel. So whenever any fault occurs, this relay and protection system will come into picture to isolate the faulty part. For this protection panel, we have to design and everything. This supervisory control SCADA system or substation SAS system, this is also used through soft, that means without using the panels, it is from computer, you can, from remote, you can operate this breaker and isolator. That is substation automation system. Metering system, that is required for how much power flow is taking place, energy. Communication system, this communication system is used for two purposes. One is for protection purpose, another is for communication between substation, sending end and receiving end substation. So there are so many slides. Okay, I'll finish it quickly. Let us go back to the position secondary system. Control and protection. Next, secondary system, communication system. This is between two substation. There is PLCC system, and within the substation there is fiber optic connectivity. And within system there is fiber optic connectivity, that is for this substation automation system. And between two substation there is PLCC system or fiber optic system is also there for connecting telecommunication. Okay. And within the system, this EPAX means basically telephone exchange, and public address system is also there in case any emergency announcement is required when people are working in the field and something happened. So immediately it was announced through public address system. So public address system is get there. Okay, my next slide. Auxiliary system. Auxiliary system, there are 2-3 systems. Apart for making these system main primary systems running, primary and secondary system running, we have these auxiliary. We need auxiliary system. Auxiliary system is basically 415 volt AC supply system and 220 volt DC supply system. These relays are operated through 220 volt DC system. All protection scheme. All control system is operated through 220 volt DC system. So for this control and protection, we need 220 volt DC system, and also we need 415 volt AC system for running all motors. We need 415 volt AC system. The breaker have motors, isolator have motors, rotating equipments, all these are. So for running those motors, we need 415 volt AC system. And again, that AC system has main system, backup system, so that never power complete failure of power. In case of complete failure of power from auxiliary transformer, then there is backup of DG set. So we have to, sometimes we use UPS for these computer systems, SAS system. We have to keep the computers always running. So we use UPS. Okay. DC system, for DC system, what we do? We have battery charger and battery. Battery charger is basically, it is a converter, rectifier. It converts AC power into DC, and that DC is used for my protection system and control system. And at the same time, we have battery bank as a backup DC source. And this battery charger, battery, and my load, all remains connected, so that suppose there is some fault in auxiliary transformer, my AC supply, incoming AC supply is switched off. So immediately the DC supply will be transferred automatically to battery, so that there is no interruption of DC supply to relays and control systems. Because fault can occur in an electrical circuit, it takes some milliseconds to occur a fault. So we cannot afford to have change the DC system switched off for few seconds. No, not possible. So we have to design in such a way that if the AC power is off, my battery charger fails, automatically DC, my battery bank will come into service without any time lapse. And all these equipments are connected through cables. So we have to design the cable system. It is HT cable and LT cable. LT cable means all small 415 volt supply is done through LT cable. Apart from that, we can use HT cable for 6.6 kV, 11 kV for charging auxiliary transformer. So these are cable system. Okay, cables are run through cable trench, on cable tray placed in cable trench. Then cable accessories. For connection of cables at the equipment, we need cable gland, termination, ferrules, etc. Then there is illumination system. We have to illuminate the entire switchyard, because after sunset, we have to work in switchyard, we need illumination. So we have to design an illumination system. We have to put an illumination system in place so that people can work 24 hours. Next slide, ma'am. Then one auxiliary system is fire detection system, and each building in switchyard, control room building, panel, control panel, building, relay panel room, everywhere we have to put this fire detection system. For transformer, reactor, we have to put fire detection system. Anytime fire occurs, the firefighting system will come into service automatically. Here nothing is manual, everything is automatic, no time delay. This firefighting system is for transformer, reactor, control room building, panels, everywhere. Then comes air conditioning and ventilation system. So each panel room has to be air conditioned. Control room has to be air conditioned, and the administrative building where the officials will work, that has to be air conditioned. So we need air conditioning system. Next slide, ma'am. Now comes civil work. Civil work, we know it is a basic of all everything. Until and unless there is civil foundation, nothing can be erected. No equipment can be erected. So for all foundations, we need civil work. There are many civil works in a substation. Many things are there. Tower and equipment foundation, transformer, reactor foundation. For every equipment, there is foundation. For running the cables, we need cable trench. Okay, then we need a road within the substation, rail cum road. For a transformer, we have to make the rail cum road from the main switchyard road to the transformer plinth, transformer foundation. Because when transformer is a very big equipment, it weighs around 80 ton, 90 ton, 100 ton. So it comes on trailer. So how that trailer will maximum come on this that road, switchyard road. But from this road, how I will take this transformer to its foundation. It is no such big crane and everything. So we put rail cum road from this switchyard road up to transformer plinth. On this rail, the transformer is pulled from this road to its location on the plinth. So for that, rail cum road has to be prepared. Drainage system has to be prepared. Fencing and gate for isolation of the charged area from non-charged area. Anti-weed treatment and stone filling. You know, for this step potential and all those things, every substation surface is filled with stones. So thickness of that stone is designed depending upon that step voltage and soil resistivity and everything. Okay, and before spreading the stones, we do anti-weed treatment so that on the soil underneath, so that every time, during weeds grow very rapidly. To prevent those rapid grow of weeds, we have to do anti-weed treatment of the soil before spreading the stones. Then there is control room building, service building, firefighting pump house building, fire water tank, DG building. All these are buildings that is constructed by civil department in each substation. Next slide, ma'am.
Sir, our time is 9 p.m. is the last time. Some participants are leaving. You can conclude at earliest, sir. It will
But
be better.
another 2 to 3 minutes. I'll conclude.
Yes, sir. Okay, sir. Thank you.
Show me. Okay, this is a sample drawing. Everything, this equipment foundation, tower foundation, transformer foundation, control room building, this cable trench, road, all are shown here. This is an indicative plan of civil works. Okay, next slide, ma'am. Other civil works, land development work, retaining wall, boundary wall. When a project starts, generally we get our land which we have to develop according to our requirement. It is not labeled. Any land comes. Sometimes we have to, the height is more than our required level. We have to cut the soil. Somewhere it is below the required level. So we have to fill the soil there. So we have to first develop the land, and then we have to put a boundary wall across to the project premises. So these are another civil works we do generally. Okay, next, ma'am. Structures. All equipments are placed on structures, isolators, CT, CVT. We make civil foundation. It is up to ground level. But as for safety clearance, we have to put the bus bar equipments at certain height. Somewhere it is 6 meter, 8 meter. So what we do, we put some structures on the civil foundation, and on that structure we place the equipment. So structures are there everywhere. You will see some photographs. You will understand how the structures are used. It is used for supporting the bus system, rigid bus system, stringing system, and everything. Next slide, ma'am. These are some photographs. This is a substation in Himachal. We have first developed this land. There, the profile of land is not this. So we have to make this horizontal piece of land before making foundations. And after foundation, the structures are developed and all equipment erected. Okay, next, some photographs are there. These are the towers and stringing is done. Next, ma'am. This is the stone spreading work is done after anti-weed treatment. Next, these are breakers, circuit breakers. Actually looks like that, and it is connected through aluminum tube to isolator. And the connectors are everywhere. You see, this is one connector. Here is some connector. I was talking about these connectors. Next slide. This is photograph of isolator. This is a center break isolator. There are different type of isolators. Double break isolator, tandem isolator. This is center break isolator. Okay, next, ma'am. This is one substation photograph of how all things are connected. This is main tower, and these are beams. This is called beam. In this beam, the stringing is done for busbar system. This is a flexible busbar system to this beam for 3-phase. It is a complete bay. It has 3 bus for 3 phase, R phase, Y phase, and B phase. And these are all in below, these are equipments. CT, breaker, and they are connected through aluminum tube, rigid bus. This is rigid bus connection. This is a big jungle of structure and metal. Okay, ma'am, next. This is civil work we have shown. A foundation is, a tower foundation is how it is prepared from the very beginning. First excavation of soil, then according to the design, we have to put the raft. It is called raft. This is MS rods, steel. Then there is a cage of this steel. Then we do that concreting, this concrete mixing machine, it is pouring the concrete. Then this part is called raft, and this is called column. After casting of raft, we put casting of column takes place, and then finally foundation. After completion of these columns, we backfill the area and plane. And now these are 4 columns completed and backfilled. This is a sample of civil work through photo. Next. It is a blank slide. Next. Okay, thank you, ma'am. Thank you, everybody. Many participants have left. I have made all people bored. Sorry for that.
So it's also a nice presentation. Thank you for valuable words. In this session, you explain different types of substations and their design along with their operation and control. You also discussed the different schemes of protection.
Yes.
Thank you. Thank you for your valuable lecture. I think your lecture will be beneficial for the participants.
Okay. Thank you.
Dear
Thank you very much, Kabir. Thank you.
Thank
Ma'am,
you.
thank you. Kaveri ma'am, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
And thank you to all participants. I think I have not made you people much boring.
No, it's
No, sir.
nice
No
presentation.
problem.
It was a practical exposure to the participants. It's rare actually. All are from the academic backgrounds, and you are only for the first resource person who is from the industrial background. So it will be definitely beneficial for our participants.
I think one Shubham Kurdash has raised a hand. You can ask any
Yes.
question. Okay.
Oh.
He is telling that if possible, please share the PPT to us.
Hello?
Okay, you can. No issue.
Yes, sir.
Hello, sir. I am Ilango. The presentation is very useful, sir, and it is very much beneficial, sir. Since we have gained a lot of knowledge, really a wonderful presentation, sir.
Thank you very much.
Thank you, sir.
Thank you, everyone. We'll start our next session tomorrow at 6 p.m. Thank you and good night to all.
Thank you. Good night.
All participants are requested to submit the Google form for their attendance. I have sent 2 Google forms. You please fill up all the Google forms. 2 Google forms. Okay. Thank you, sir. And thank you all.